Hello everybody, I am Samiha Ahmed, chemistry teacher at STEM Alex School. Today we will talk about LO13, grade 10, electrochemistry. You had to read our textbook and resources material in Active Chemistry Chapter 4, Section 4. We want you to use understanding of metal activity series to explain why metals are found as they are in nature and discuss consideration for the use of metals in industry, constructions, and jewelry. Our concepts for this LO are metals, oxidation-reduction reactions or redox reactions, oxidation, reductions. What about our skills? Oh, we are sorry for being at home. Really, we miss our lab. Next year, inshallah, we will do it. We will test the chemical reactivity of metals, use metals to light an LED, and explain the procedure and how this can happen. At the end of our session, I hope you will be able to know what enables metals to have the properties that they have. Yes, we can also have integration with earth science LO9 and with mass LO5. First of all, I want you to know that when a metal atom reacts, it gives up one or more electrons and becomes a positively charged ion. For example, the equation that shows how a silver atom gives up electrons and become a silver ion is, yes, silver Ag produces Ag positive 1 as silver ion and 1 negative electron. This means that when a neutral atom of silver gives up 1 electron, the silver ion has a charge of positive 1. Now, we have a special reaction between metals and metal ions. For example, the reactions that can occur between neutral metal atoms and metal ions are a part of special class of reactions called oxidation-reduction reactions or redox reactions. What do you know about oxidation? Yes, it's giving up electrons. So, all of the equations you listed in the activity series represented oxidation. For example, zinc metal oxidizes, producing or losing 2 electrons. What about reduction? Reduction is receiving electrons. An oxidation equation turned backward represents reduction. For example, copper ion reduce, yes, gaining 2 electrons, producing copper metal. After being understanding about oxidation and reduction, you had to know that when an oxidation happens, a reduction also occurs. Electrons that are given up have to be received by something. So, oxidation changes and reduction changes are often called half reactions because you need both halves for the reaction to be happened. So, you can use half reactions to balance redox equations. How? Yes, by making sure that the number of electrons lost is equal to the number of electrons gained. For example, one zinc metal oxidizes, the copper ion will be reduced, as we will see in the equation. When metal zinc oxidizes, it loses 2 electrons, giving zinc ion. What happened to the copper ion? Yes, it gains the lost 2 electrons, forming copper metal. We can deal with the redox equations as in math. Since the same number of electrons are lost as are gained, the half reactions can be added as they are. and the electrons will be cancelled. This gives the redox equation. Yes, zinc metal plus copper ion producing zinc ion plus copper metal, as the electrons are cancelled at the both of sides. Now, you learned that although you can write the equation in two directions and you can test both equations, the reaction will occur naturally in only one direction. For example, for the pair of metals, zinc and copper, the two possible equations are as follows. Zinc metal plus copper ion changes into zinc ion and copper metal, or copper metal plus zinc ion, yes, changes into copper ion and zinc metal. Now, I want you to tell me, how can you predict which equation will be represented? Yes, the activity series can be used to predict this. Finally, I hope you can recognize that redox reactions generate electricity. Yes, electricity means moving electrons, as there is losing and gaining electrons. Now, try to answer the form given on your team page.